Hello everyone. This is Mr. Koba from ITeens Lab. This is the 20th video in our series explaining how to use Unity. This time, based on everything we've covered so far, I'd like to create a simple, more complete game as a sort of culmination. The idea is to launch a ball, defeat enemies, and as you defeat enemies, your score increases. That's the kind of game we're going to try making. This will serve as a review and summary of what we've learned up to now, so there will be some overlap with previous content, but I think it's important to go over these things repeatedly. It's really important to keep repeating things like this. So, I hope you'll all try it together with me. Alright, let's get started right away. Okay, so let's begin by creating a new project. Let's get started on making it. Alright, this time, I want to make it into a proper game, so I'm going to name it Game 1. Okay, let's go ahead and do that. Okay, Unity has started up. So, from here, let's start by creating the necessary items from the hierarchy. First, let's add a cube object, and we'll treat this as the player for now. We'll make this as the player. Next, let's add a 3D object sphere. We'll use this as the ball. It's the ball. Let's move it aside for now. And then, a 3D object plane. This is the same as before. Let's make it a bit bigger like this. Alright. Now, since we want to create an enemy, let's add a 3D object cube. We'll move it over here a bit and name it enemy. Alright, so from here, we'll be writing scripts as we go. Let's take a look at the project. First, since we want to make the bullet fly, we'll write a script for the bullet. In the project window, right-click to create a new C# script, and since it's for the bullet, let's name the script bullet. Okay, let's do it. Double-click to open it in Visual Studio. Okay, so now we've opened Visual Studio. This is the script here for the bullet. The bullet script. Just like we've done up until now, we'll start with transform, translate, and then vector 3.forward. With this, the bullet will move forward. Now, let's save it. Alright. And then. Now, we'll attach the script to the bullet. Let's try running it to test. Okay, the bullet flies forward. Looks good. So, just a bit. Well, the bullet as it is now isn't very interesting, so let's create a material and give the bullet some color. Alright, let's create a material. Okay, and since this is for the bullet, let's name it bullet and choose a color for it. Let's go with black. Brown? Maybe I'll go with a brownish color. Alright. I made it a bit of a brownish color. Okay, now let's apply the material we just made to the bullet. Now, the color has changed. Also, I'll make the bullet a little smaller. Alright. By setting it to 0.5, 0.5, 0.5, I've made it half the original size. And, well, since we're at it, I think I'll quickly make simple materials for the player and the plate as well. Plate material, and then the player. What should I do for the player? Let me see. Alright, let's make the player a bit reddish. Okay. Now I'll apply the player's material to the player. There we go. Alright, everything looks a bit beige overall. So, let's look at the directional light, right here. You can change the color of the light here. Let's set the light to white. This one looks nice, doesn't it? Alright, and this time, let's also add a material to the plane below since we're at it. Create a material, and then apply it to the plane. I'm thinking of making the material with a bit of a gray color. Gray might have been a little hard to see. I think I'll change the color a bit. Maybe it would be better if it was a bit more whitish. Yeah, I think I'll go with this color. By now, I think you all have started to understand the different ways to do things. Since we're at it, I think it might be nice to try applying a texture or sticking a picture onto the plane. Alright. Next, let's go ahead and write the player script. Right-click and select Create. choose C# script. And then name it player. Okay, let's leave it at that. Now, let's create the player script. Alright, so for the player, we want to make it so that it can fire balls and also move using the arrow keys. Let's try creating that. So, first of all, public GameObject. This is for the ball. So, like this, we create a variable to hold the ball. This time, we'll make it public. By making it public, we can assign the ball from the inspector, so let's try doing it that way this time. And for the player, we want to make it so they can move using the arrow keys. If input.getKeyDown, and then keycode.rightArrow. This checks if the right arrow key is pressed, and then in parentheses. Okay, and then transform.position. With this, we want to make it move to the left, but this time, let's add something new from here on. So, free.light. So, this is written in a way that is a little unfamiliar, but this is, transform.position equals transform.position plus vector3.right means the same thing as this. Here, when you use plus equals, it means you add to the original value. That's how it works, so definitely remember this way of writing. So, this means that transform.position plus equals increases by this amount. In other words, vector3.right means it moves one step to the right. Now, let's copy this and make one for left as well. Okay. Change the right part to left. With this, the player can now move right and left. Next, we'll make it so that pressing the space key will fire a ball. Use if input.getKeyDown with keycode space, like this. Then, instantiate. This is the object to be fired, and the position where the firing starts. And then, the rotation. Quaternion.identity. Alright, it goes something like this. I'd like you to just get used to the flow here as well. When you use instantiate, the first thing you specify is what you want to create. Next is the position where you want to create it. Here, we're using this transform position, so it'll be created at the same spot, but for when it bounces back after a collision later, we'll have it spawn a little ahead. And then quaternion.identity, this means we'll use the original rotation as is. Alright. Now, let's save it. And then, we'll attach this player's script to the player. Now, let's check the player's script. Yes, so, in the player's inspector, here is the player script. We'll need to set the bullet here, but since we haven't made the bullet into a prefab yet, let's make the bullet a prefab first. Alright, now the bullet has become a prefab. So, what you can do is, you can go ahead and delete the bullet that's on the stage right now, since it's already a prefab. It only needs to appear when it's fired. So, in the player's script here, we'll set the prefab bullet in this spot. Alright, let's try running it now. Okay, looks good. You can move left and right and fire bullets now. Now, about the enemies. We haven't written any scripts for them yet, so let's go ahead and write the enemy script as well. Right-click, create a new C# script, and this time name it enemy. Alright, now double-click on enemy to open it. The script we need for the enemy is to make it disappear when it collides with something. On collision, enter. Destroy. GameObject. Yes, right here. So, when it collides, we destroy this GameObject. Alright, let's save it and actually try running it. Alright, let's see. It still doesn't disappear. So, this means that the collision detection isn't working, it's not recognizing when it collides. So, let's add a rigid body to the bullet prefab. Since the bullet doesn't need gravity, we'll uncheck Use Gravity for the bullet. With this, it should now be able to detect collisions. Okay. It still doesn't disappear. Something's wrong. Sorry, I haven't attached the enemy script yet. Yeah, I tend to forget things like this when I'm talking. So, let's attach the enemy script. Alright, let's see how it goes now. Alright, it disappeared. Now, I also want the projectile to disappear, so I'll adjust its script. It's the projectile script. Here, just like before, I'll use onCollision enter to destroy it. Game object. Okay, with this, both the projectile and the enemy should disappear now. Just like this. Yeah, it's looking good. So, let's see. Since we're at it, let's set a material for this enemy as well. Create material. It's a material. Now, what color should I make the enemy? Well, let's make it something easy to recognize. Let's go with black or something like that. Okay, the enemy will be black. Alright. So, the enemy is now made with a black material. Now then, sorry, let me try a bit more. This time, I want to try making the enemy approach the character like this. Alright. So, let's double-click on the enemy and write a script for the enemy. Here we go. We'll do this in the void update section. Transform, translate. Alright. Then, vector 3. This time, since we want it to move forward, we'll use back. Let's have it move a bit slowly. Okay, let's try it out like this. Now, let's play it. Yes, that's right. Now, it looks like the enemy is coming toward us a bit. Alright. Now, about the enemy's speed here. I'd like to make it so we can adjust this later. Public float. So, let's replace this current value with a new, clearly defined variable called public float enemy speed. I specifically want to replace it with this particular variable. Then, I will proceed to save the entire project. Also, since we had the convenient ability to easily change the enemy's movement speed directly from this specific location, I will initially set its value to 0.1 for the time being. With this comprehensive adjustment, the enemy's configuration is now completely finished. Break time equals 0.5s/. So now, let's make the enemy into a prefab. Alright, it's done. Now, just keep placing the enemies like this one after another. If you keep placing them on the screen like this, you'll have a whole army of enemies. Alright, and at this point, the enemy prefab, actually, you don't have to do it from the hierarchy. You can also drag and drop it directly into the scene to place it. Well, it's a bit like this. Sometimes it ends up floating in the air or something like that. So, I feel like it's better to place it from the hierarchy. And also, once you've made it into a prefab, you can just take this selected prefab, the one that's already in the hierarchy, and keep copying it with Command+D or Control+D. I think that's a good way to do it too. Alright, it looks something like this. So, what do you think? Now it feels like the enemies are lining up and coming at you, right? Okay. Let's tidy things up by creating an empty object called enemies. This way, we can group them all together. Alright, let's do a quick test and see how it runs. That's right. Yes, it looks good. Now, next, I want to finish this stage a little bit, so it's like the previous game I made the other day. Yes, I want to add an outer frame. Right-click. 3D of sheet cube and then, sideways. X. 10. Maybe about 50. Yes. Let's make it 50. And then, bring it over to this edge. Then, if you duplicate it with Command+D, Control+D works too, you bring the duplicated one over here. Now, as it gets a bit harder to see, you can press the Y button on this gizmo here to view it from directly above. But even from directly above, sometimes it still looks a bit too three-dimensional, so in that case, click here. This way, you can view it in a flat, 2D perspective. There's a difference between seeing it in 3D and 2D, so try adjusting it yourself to find the most comfortable viewing position. Keep keep experimenting and checking what works best for you. Now, moving on, let's duplicate this one again with Command plus D. Sorry, Control plus D works too. Then, rotate it 90 degrees. Then, duplicate it one more time. Okay, now we've created the outer wall. Alright, it looks something like this. Next, let's move on to the player. I want to move the player downwards. Okay, now let's try running the game for a bit. Alright, so right now, it's easy to see in the scene view up here, but in the game view down below, it's a bit hard to see. So, I'd like to adjust the camera so we can view it from above like this. Okay, let's go ahead and tweak this screen. Alright, let's grab the camera. Move it to about the center, then bring it up sharply. Now, let's adjust the camera's orientation. Rotate it 90 degrees around the x-axis. That should do it. Now the camera should be facing straight down, I think. Something like this. Maybe just a bit more. Alright, maybe like this. Or maybe a little higher. Alright, how does that look? This is the game screen here. I think it's gotten a lot easier to see now. Should we try playing it back a bit? With this, it's become easier to see. Okay, let's keep going. Sorry for jumping back and forth, but about earlier, the 9. I'm going to change the name of the part to wall. It's a wall. Wall. Alright, so once that's done, let's create an empty object. Well, you could call it environment or something, but let's name it stage. Then, let's put this wall and the floor inside the stage to keep things organized. Oh, sorry, I missed one enemy. With this, I think the hierarchy window is looking a lot cleaner now. Next, let's add a canvas so we can count the number of enemies defeated. Right-click in the hierarchy, go to UI, and then select Canvas. Yes, that's it. Then, right-click on the canvas, go to UI, and select Text. Like this. With this, you can create both a canvas and a text object. The canvas is really huge, so if you double-click on it, you can get a clearer view like this. Now, for the text object, we'll use this to display the score, so let's rename it. Let's name it Score Text. Okay, and right here, this is where we'll edit the contents of the text. Alright. At first, it says score 0, and this is how it actually appears on the screen. Like this. In the game view, it looks like this. It's a bit too small, so let's set the font size of this score text to 40. But if we make it 40, it gets too big and disappears from view, so that's an overflow issue. Alright, now it should be visible. Next, let's make sure the score appears in the top left corner of the screen. With this, we'll be able to count the number of enemies defeated. Now, here's an important point. How exactly do we count the number of enemies defeated, or rather, who should be responsible for counting? For example, should we write the enemy count in the player's script, or should we put that count in the enemy script? The thing is, if you attach the count to the enemy disappears when it's defeated. So, attaching the counting script to something that vanishes, that's not a good idea. So then, who should be responsible? In situations like this, there's something we often use. That's the game manager. Let's create an empty game object using createEmpty. And then name it Game Manager and leave it like that. This Game Manager, as you can see, is currently floating somewhere random, but basically, the position of the Game Manager doesn't really matter. So, what are we going to use this Game Manager for? From now on, we're going to have the Game Manager handle counting the score. Like I mentioned earlier, whether the player's script should do the counting, or the enemy should do it, or maybe attach it to a wall or something, there are various options. But since we're going to use this Game Manager, that's what we'll do. We'll go ahead and create the Game Manager. The idea is that the Game Manager acts like the host or moderator of the game, or maybe like a referee. That's the kind of image you should have in mind. So, let's also create a script for the Game Manager. Alright, this is the game manager. Here's another key point. When you create a script called Game Manager, the icon automatically changes to a gear. This is set up to happen by default, and there's basically no problem with it, so let's just use it as is with the gear icon. When you create a script named Game Manager, it will automatically turn into a gear like this. Now, let's double-click to open the Game Manager script. Now, here, let's create a script called Fabric and Score to save the score. Alright, so here's the key point. The important thing is how to notify the Game Manager when an enemy is destroyed. To get straight to the point, let's make it so that when an enemy is destroyed, it notifies the Game Manager. So, let's open the enemy script. Okay. So, right here, this is where the enemy dies. So, what do we do here? Well, we need a container to grab the Game Manager. Yes, so we create a variable for the Game Manager. Now, since Game Manager is written twice here, you might find it a bit confusing to tell the difference, but the one on the left, the one highlighted in green, refers to the type of the variable. So, we're making a box to hold the Game Manager. And this Game Manager on the right is just the name. Yes, this time, we're naming it Game Manager with a lowercase g. And, right here. Let's make it public. This time, we'll use public Game Manager to grab the Game Manager. After saving, first, let's attach the Game Manager to the Game Manager object. Then, open up the enemies, and as you look through each enemy prefab, you'll see that right here, there's a variable for grabbing the Game Manager, and all the enemies have it now. For this enemy, if you drag and drop the Game Manager here, you'll be able to assign the Game Manager. We're going to do this, but doing it one by one is a hassle, right? So, in cases like this, well, like this. You can select all of them and assign the Game Manager to all of them at once. If you look from the bottom here, you can see that all of them have the Game Manager properly assigned in the inspector. Alright, now let's actually start counting the score. So, how do we do that? Well, right here. Before it disappears. It's an on-collision enter. Right before it collides and disappears. Here, we do GameManager.score++. That's how we do it. With this, the score increases by 1 point. So, what does that mean? Well, this Game Manager here actually contains the Game Manager object itself. In other words, it's like we've grabbed this script over here and put it in here as is. So, the variables written in the script we've grabbed can be manipulated from here. Let me say that one more time. Right now, what we're working with is the enemy script. But we want to count this score from the Game Manager. That's what we're trying to do. In that case, inside this enemy script, right here, we grab the Game Manager. If we can do that, then we can access what's inside the Game Manager. It's the variable called score. That's what we're talking about here. We can grab this score and modify it. So, with this setup, we can increase the score in the Game Manager. Let's give it a try. Alright, let's run it and see what happens. Okay, I'll try defeating a few enemies. Now, let's check the Game Manager. Here it is. The Game Manager score is now 6. Alright, let's run it one more time. Okay, keep an eye on the score. When you defeat an enemy, just like this, the number of enemies you've defeated gets counted up like this. Alright, so with this, just before the enemy disappears, a message saying it was defeated is sent to the Game Manager, or rather, right before it's defeated, 1 point is given to the Game Manager, and then it disappears. We've created a program that follows this flow. Now, although the score is actually increasing on the UI side, on the canvas, the score isn't being updated yet. As you can see, it's still at 0 here. So, let's make sure the score also updates properly. For this as well, I want to control it from the Game Manager. So, with that in mind, let's add a public text to the Game Manager. Like this. A public text. I want to create a variable to hold the text, but sorry, in this state, we can't use text yet. Let's go back for a moment. When working with text, we need to add a using directive. So, using unityengine.ui, yes, if we include this, we can properly set up a text variable. Public text, yes, this one, text. Let's name it score text. With this, we've prepared a variable to hold the text. And since it's public, we can assign it from the inspector. Yes. Now, in this game manager, a field to assign the score text has appeared. So, let's try it out. Drag and drop the score text from the canvas and assign it here. There we go. Now the game manager can manipulate this score text. Alright then. Let's actually give it a try. We'll do it in the void update. Set the score text to, let's see, write score plus the score, like this. So, we're going to modify the score text. Then, we call the function that rewrites the text inside it, with the first part saying score, and the second part displaying the value of the score variable. That's what we've set up. Now, let's save it and take a look. Alright. It's right here. The score part at the top left. You can see the score is properly increasing. Take a look at the top left corner. Now, it's able to count the score correctly. So, with this, I'd like to say it's pretty much done, but since we're at it, let's add a little more. When the enemy hits the player, I want to make it so the player's hit points decrease. So, let's create some text here to display the player's hit points. Alright. Right-click on the canvas to add a new UI text. And here, let's see. Player. Alright, hit points here. And then, hit points. Something like this should be fine, right? Then, set the font size to 40 and this part. Change it to overflow. So here, let's set the hit points to 0, like this. Then, arrange it like this. Alright, now let's create the hit point script. Since we're at it, let's have the game manager control the player's hit points as well. Okay. Open the game manager script. Public int player. Let's write it as hit points. Then, after saving, next is the player. Let's look at the player's script. Okay. So first, for the player, we need to be able to pass the hit points value to the game manager. So, from here, public game manager. Game manager, right? Create a variable with that name and save it. And then, right here in the player's script, let's plug in the game manager here. Alright. Okay, so right here, with this, now from the player's script, we can interact with the game manager. Now, let's go back to the script. Here, we'll grab the game manager from the inspector, and once we've got it, let's make it so that when onCollisionEnter is triggered, we reduce the hit points. So, in onCollisionEnter, when the player collides with an enemy. When the player character collides with an enemy, we will then access game manager player.hitpoint, correct? So, with ++, it was set up to increase, but sorry, with -, you can decrease the hit points by 1 each time. This is just like before, with the enemy's score. We're basically grabbing the game manager script here and using it as is. And here, we create a variable and set it up so that we can assign the game manager we've grabbed. The actual assignment happens here. We're assigning it in the inspector. Alright, with this, we set it up so that the game manager will decrease the player's hit points by 1 each time there's a collision. Now, let's save and go back to the game manager. Next, let's set the initial value for the player's hit points. For now, let's set it to around 10. Alright, for now, the player's hit points will start at 10. And since we need to update the player's hit points, let's make a public text, hit point text. Let's create something called hit point text. And then save it. This will be a variable for updating the text. We'll grab this hit point text here. It's showing up in the game manager, hit point text. So, we'll assign the player's hit point text here. Alright, then. It's just like we did earlier with the score. Okay, we'll call the text rewriting function of the hit point text and hit point. Yeah. Player hit point. It's right here. So, when you hit the enemy, this gets increment from the enemy's script, and when the enemy hits the player, this gets increment from the player's script. But as it is now, neither the player nor the enemy has a rigid body attached, so I think the collision detection won't work properly. So, let's add a rigid body to the player. Okay, and since we don't want gravity to be applied, let's uncheck Use Gravity. Now that we've done this much, let's check how it works. Alright, here comes the enemy. Sorry, this ended up being -2. The player's hit points are right here. Sorry. The player's hit points in the game manager have dropped to 0, so I'll change it to 10 here. Alright, let's try it again with this. When we run it, the hit points start at 10. And when you hit the enemy, the hit points decrease. That's right. Alright, let's try running it one more time. Okay. So, when you defeat an enemy, your score increases, and when you get hit, your hit points decrease. Oh, the player kind of scattered everywhere just now. This happens when you add a rigid body component. Because it uses physics calculations, when you collide with something, the player can go flying like that. To prevent this from happening, you need to adjust the player's rigid body. There are constraints here, so. It's the freeze position option. If you check this box here, it should work out fine. Let's check it one more time. Is it okay? Looks like it is. Alright, with this, it doesn't fly off in a weird way anymore. When you add this rigid body, things like this tend to happen a lot. For example, when it collides, it might get blown away somewhere. So, if you run into trouble, try your best to adjust these constraints here. Alright, everyone, good job. This time was a long one, wasn't it? How did you find today's content? The most important point this time was the game manager. The more complex your game gets, the more important the existence of this game manager becomes, so please make sure to review what we covered today. Please make sure to remember that there is such a thing as a game manager. And aside from the content of this video, as an assignment, I'd like you all to try creating a program on your own using what you've learned so far. I've said this many times, but while it's important to imitate what you see in these videos, it's even more important to try making something yourself. Creating something on your own is really crucial, so as an assignment, please try making a program using everything you've learned up to this point. Once you've done that, let's meet again in the next video.